to infinity. Okay. Does this relation represent y as a function of x? That's the first question. If yes, what's the range and domain? Is this a function? Based on our description of how to tell if a graph is a function, is it a function? Well, do we have y's repeated? And one way to tell on a graph is to draw a vertical line. If it touches two places, it's not a function. So this is not a function. Easy answer. If it's not a function, it doesn't have a range and domain. We don't worry about that. So our answer is just not a function. Okay, does this relation represent y as a function of x? Okay, so basically, is this a function? If it is, then we'll go on to find the range and domain. So now we have points, okay? We have the point 3, comma, y, and y can be any number between -2 and 4. So let's write out a few of the points. So we can have 3, -1.5, okay? Or 3, -1. We could have 3, 0. We could have 3, 3. We could have 3, 1.675. Okay, y, notice, was any number between -2 and 4. We could pick anything, right? But x was restricted. It had to be 3. Remember what gave us whether or not it's a function? If x is repeated, is it a function? No. The reason it's not is because with functions, we want to know exactly what's coming out. And when we put in 3, we could get anything between -2 and 4 and not just one exact number. The graph of this would look like a vertical line at 3. That goes from where y is -2 to where y is 4. Okay, not that. But when you look at something like this and it says all of your x's are going to be the same number, it's not a function. So once again, since this is not a function, our answer is just not a function. Had it been a function, our range would have been between -2 and 4, and our domain would have been 3. But it's not, so we don't worry about that. Does this relation represent a function? If yes, what's the range and the domain? Is this a function? Well, when you're given a graph, are any of the x's repeated? When I draw a vertical line, do I touch more than one place on the graph ever? I do not. Each of those points has its own x value, okay? So this is a function, finally. Yes, it's a function. So we're supposed to give the domain and the range. Now notice they're not connected by a line. If they were connected by a line like that, that would make our range and domain different. But they're not connected by a line. Okay? They are just distinct individual points. So our range and domain, we will just list the exact x values and y values. I'm going to have to kind of guess because my graph wasn't fantastic. But I have an x at -3 for x, -3, 1. This one was -1, 3. This is at -1, 1, -1. And this one is at 2, 2. So my domain is all of my x values, which would be -3, -1, 1, and 2. My range is all the y values, which would be 1, 3, -1, and 2. There's my domain and my range. Here's another example. Does the relation represent y as a function of x? If it is, what's the range and domain? Okay, here's the description. We have points x, y, where x is an odd number and y is an even number. So the question is, to be a function, can I have an x paired with more than one y? Well, let's see. if x is an odd number, it could be 1. Y just has to be any even number, so it could be 2. X has to be odd, it could be 1 again. Y has to be any even number, it could be 4. Okay, we do have other points, like 3, 6 would be a part of this relation, and 5, 10 would be a part of this relation. But notice we could have an infinite number of points that have x as their 1 and a different y. Remember, the rule for a function is you can't repeat x values, and this would repeat them over and over again. We could have lots of points where the first coordinate is 1 and the second coordinate is an even number. So this is not a function. Okay? And finally, does the relation represent y as a function of x? What's the range and domain? With graphs, what we want to do again is draw a vertical line and test to see if it touches more than one place on the graph. And if there is a place, you're going to find it right away. You'll see that you would have touched 2 places. But notice each of these points, each of these lines only touches 1 spot on the graph. Even as steep as this line gets, we'd still only touch 1 point. So this is one of our yeses. It is a function. Now we have to identify the range and the domain. Okay, so the domain, I'm going to put D, is our x values. So again, what we want to do is find our furthest x to the left. There's no arrows there, so we know our graph stops. And our furthest x value to the right, you look left and right for x's because they go left and right. And we write down that interval. It starts where x is -4, and it ends where x is 3. So our domain is from -4 to 3. We are going to include those because of the closed circles there. So this is not, once again, this is not the point -4, 3. It means the interval starting at where x is -4, going clear to where x is 3, and everything in between. We cannot just write down individual points that we see on the graph, because if you write down individual points, you're leaving out all of those things that the line was used to connect. Let's try the range now. The range is our y values. Y's are up and down. So for the range, I want to find my highest point on the graph and my lowest point on the graph. Okay, so here's my lowest that it dips. And here's the highest that it reaches. So we cover all of the y's. Notice there's no breaks or gaps. We cover all of the y's between -2 is our bottom, and the tops out at 5, where y was 5. So our range is from -2 to 5, starting at -2, ending at 5, including both of them. There you go. There's our domain and range. Domain and range can be a tough concept to kind of see, but just remember the domain are your possible x values and the range are your possible y values.